Okay, welcome to example 12. We have a block, mass M, 1.2 kilograms, that's in contact with a vertical wall. We're given the coefficient of static friction, which is 0.45, and we want to know what the horizontal push force is required to prevent the block from sliding down. So your first step is to draw a free body diagram. So there's your body. What force would be acting on it? Well, we have pushing inwards, that's what we're trying to find, F. Put F equals question mark. We have something that's got to oppose that. That's that contact force from the wall pushing back. That will be our normal force that's perpendicular to the surface, F sub n. That's the force coming from the wall. We have gravity wanting to pull it down, but something is preventing the gravity from pulling it down, sliding down, and that must be friction coming from the surface, and there's FF. So this problem is really a static equilibrium problem because it's not moving. So that means that the acceleration is 0. It's in equilibrium. So we go ahead and apply our Newton's laws. Assuming that y is up and x is to the right is positive, we sum the forces in the x-axis, come out to be 0. We also sum the forces in the y-axis, that should come out to 0. We look along the x-axis, we have two forces. We have the force that we push with inwards minus the normal force, which is equal to 0. So the pushing force must be equal to that normal force. So we really need to find that normal force. Where is that going to come from? That must be coming from the y-axis. So looking along the y-axis, we have friction upwards minus force of gravity downwards, which is equal to 0. And you hopefully realize that the force of friction formula is equal to mu s times Fn. There's where the normal force is going to come around. So we have mu s times the normal force equals the force of gravity, which is equal to mg. Hopefully you recall that as well. And we need to find that normal force, which is basically mg divided by mu s. And that normal force is equal to the force that we push with. So m is 1.2 kilograms, g is 9.8 meters per second squared. All of that divided by our coefficient of static friction, which is 0.45. So if you run that through on your calculator, you should get 26.1. And that's it for this problem.